Hey guys, it's Jason Chen. Today we're going to go over how we wrote the system calls for this customized access level attribute for all the processes in the operating systems. So just to quickly go over what we some of the changes in the kernel, I'm going to just show you all the details are in the report. So I'm just going to go over some of the changes I made. So first we want to declare this customized variable and include Linux.schedule. So yeah, this variable is declared here in the task struct. Okay, so task struct is how a process is represented in the Linux kernel. And once we declare it, we want to make sure we initialize it with a default value of 0, which is done in the init task.c in the init folder. So here, this access level variable is declared globally and has a default value of 0. And it's also just for safety because some of the processes are copied from their parent processes, which is called a fork. So we want to make sure when we're forking, this value is also inherited or initialized with a default value of 0. So that's our attribute. Once we've set our attribute, we want to make sure we can communicate from the C libraries outside. So that's why we need to write two system calls. So one of the system calls, you can have the system call library, which is located here. Yep, and then you have the syscall table right here. So I just added 2 lines, pretty much writing with the format they have. It's a common system call, 64-bit declared wall here, and the actual implementation of these syscalls is located in sys.c. So I just put it at the end of the file, and the set method. So the first one is the set, is the get access level. So we just use this method called find task from PID. So PID, you have the process ID. With this method, it returns the pointer to the actual task struct. Okay, so if you have it as a null, you return, and then you can easily retrieve this access level. So get is pretty easy, but set is pretty much the same. There's several keywords, and you have some if logic here because you only want higher access level to change lower access level, and special case is if you're running as administrator, you can change everything because in theory you can just change the kernel, right? Right. So yeah, there is also a keyword current. That's the task struct of the current process that's running. So after we have some nice logic, we're gonna make. And then, so I already made, so we're just going to go test it now. So here, I have the libraries here. So let's remove some of these. So we want to remove the library and the .o file. So that's clean. I can just click make, and then it's going to make the library of access level and the harness functions and everything. Let's just go into it a little bit. Nano.c. Nano. As you can see, it invokes the system call, and here I used malloc to store this array and then return the pointer to the array. Same for access, and then so let's just run it. We're actually gonna have to link the libraries, but I've already done that, so let's just sudo run this access test. Alright, so super user mode. Yep, as you can see, some of these, this last one is not allowed because your access level is actually lower than yeah, then the one you want to change. And then you have the harness test. Alright. Thank you for watching. You have a nice day.